All right, yeah, please have a look at this and let us talk on it. 2 marks, 2 minutes. Multiple choice, 2 marks. It is 2 minutes. 2 marks, 2 minutes. Two marks, 2 minutes. Two marks, 2 minutes, 2 minutes. I believe you. Let me check my time again. Your 2 minutes is up. So what is the correct answer for 1.3? Let us see. A stone is dropped, so it is dropped. According to our analysis, when a stone is dropped, VI is 0. So since it is dropped, VI is 0. It's dropped from a height y above the ground. It strikes the ground after some time t. So change in time is t, change in y is just y. Let's show the diagram below. Take up what is positive. So we choose anything that goes up positive and the ground is 0. So we take the ground is our 0. It's our reference point. Ignore and we take, let me see, we take up as positive. Is up as positive. Which of the following diagrams shows the correct position time graph for the motion of the object? Number 1, position time graph, remember it's a parabola, ne? Position time graph is a parabola. So this cannot be and this cannot be. Its position time graph is given by the formula. Earlier on I said this formula is the one that gives us position time graph, and this one gives us velocity time graph. So you're plotting this against time, and the shapes are actually here for an object that is dropped. If you choose down positive, this is the graph and this is the graph. If you make the ground, this is the graph when you choose down positive, and then you make the top as reference point. This is the graph when you choose down positive and you take ground as the reference point. So now they say you must take up positive, so it means we are considering the dotted lines there, the dotted lines there. So this one will be the graph when you take the top as the reference point. This will be the graph when you take the ground as the reference point. So the graph should look like this, like the dotted lines, the green dotted lines. So which one will be that? Not that one, and the correct answer is this one. The correct answer is D. It's C. This is C. So 1.3 C. And there you have it like that. Now before we go into more questions, there's something that I want to talk about. Let me check if we are going to have something like that. No, we don't have, so it's fine. Let us move to the next question, and I'll mention this thing on the next part, just after this, solving this question. Now we have a question here. Remember, we always have to make our analysis. Analysis helps us to understand the question carefully. Understand the question correctly. Question 3, the sketch graph below shows the motion of a ball that is thrown vertically upwards from the balcony of a building. So the ball is thrown from the balcony of a building upwards. The ball takes 0.6 seconds to reach its highest point, after which it falls downwards past the balcony to the ground. Ignore the effect of air friction. So we are dealing with a situation of free fall. The only force acting on this thing is gravitational force. So it is let us look at it now. Let's analyze the information. It says from the top of a balcony, the object is thrown up. So we know that this is the initial part, and this is maximum height. This is maximum height. This is the height point, and the velocity here is 0. The time is not 0, and the displacement is not 0, but the velocity is 0. The displacement will be a value above 10, because when you take that, it takes you to the point there. There's something that I forgot to mention in the previous session, the issue of time. But now I'm bringing that slide now, and let's work on it. If it takes, say, from this point A to point B, it takes the time it takes an object to go up, it will be the same time it will take an object to move from that point to come back here. So if it takes 3 seconds to move from A to B, it will take exactly 3 seconds to move from B to C. I hope that makes sense. This is an object that goes up and comes back to the same height, and the graph looks like this. Now, if we are dealing with an object that looks like this, the motion of an object that looks like this, this object starts at a certain point above the ground. It goes up, then when it is supposed to be collected at point C, it's not collected. The thrower leaves it, and then it drops at the point that is below the starting point. So the time it takes to move from A to B will be the exact same time it will take to move from B to C. Careful there. It's not the time it takes to move from B to D. No, it's the time it takes to move from A to B. It's the same time it will take the object to move from B to C. So the object looks like that. So the situation we are dealing with here is a situation that looks like this. But the graph, now we chose the ground as the reference, the starting point as the reference point. But if you choose the point above, you just push the graph up, and it becomes a graph that looks like this one. So it means that the time it takes to move from this point, let's draw the diagram. I prefer drawing the diagram myself all the time. So in a test also you should do this, because there are points that are important. We need to, the first point and the last point, let's make it A and D. These points are important. A and D are very important. This one is point B. Let's create it. This point is a point of interest to us also, and a point, we create another point, a point at the same height as A. So we know there's information that we know about that point, point C. The velocity at A and C are equal, but they are in opposite direction. The velocity at A is upwards, the velocity at C is downwards. The velocity at B is 0. Velocity at D is V final, we don't know it now. Right now we don't know it. So this is the displacement time graph or position time graph of our object. I believe that gives us some sense. So the time it takes to move from this point A to B, it will be the same time it takes to move from B to C. So if this is 0.6 seconds to move from this part to this part, is 0.6 seconds. So to move from this part to a point at equivalent height or at the same height, it must be another 0.6 seconds. So 0.6 seconds plus 0.6 seconds, we expect this to be 1.2 seconds. So T, they already solved the point information about T, it's 1.2 seconds. Now let's go to questions and see what do they want. Number 1, they say how high is the balcony above the ground? So 3.1. How high is the balcony above the ground? The position of the balcony, it's where the object is leaving the thrower's hand. So the correct answer there will be that is 10 meters above the ground. It's measured in meters. 10 measured in meters. It's 10 meters above the ground. So this is the balcony. This is where they threw the ball up, and then they left it to come and hit the ground. The next question, T, 3.2. 3.2. Write down the numerical value of point T. We already did that earlier on when we were discussing it. So it means T, the numerical value of point T is 1.2 seconds. 1.2 seconds. It takes 0.6 seconds to reach maximum height, so it will take another 0.6 seconds to reach this point, which is the same. It's the same height above the ground as the initial position. The time that we don't know is the time here. Does it make sense? I believe it makes sense. Now let's move to the next one. This is my favorite definition. All definitions are my favorites. So define the term projectile. 3.3. Please try to define it for 2 marks. 2 minutes. I'll give you 2 minutes to define it, and you write the definition so that we all see. Please. 2 minutes. Define the term projectile. What is meant by the term projectile? So we have 2 minutes to define it. Define the term projectile. Remember, I said we are not throwing away marks. Definitions, all the definitions, you should collect marks from the definitions. They are there given in the exam guide, and we are all going to write the same definition. Don't read the definition from the textbook. Read the definition from the examination guideline. Define the term. Define the term projectile. Yes, I'll be uploading the this session later on YouTube. I'm just going to download it and upload it later on YouTube. So the definition for projectile is the object upon which the only force acting is gravitational force. Here I've given them earlier on when we're discussing. I said the definition for this is a definition for free fall. It's motion of an object. Then this part from object, if you look at the two definitions, they have a lot of things in common. Projectile is object upon which the only force acting is gravitational force. An object for which the only force acting is gravitational force. So that's there, you write it like that, and then you score yourself 2 marks. So yeah, we are done. This is a definition. It's object upon which only force acting is gravitational force. In words, please. And there we have it. Now next question says calculate the initial velocity of the ball. Initial velocity of the ball. So let's write our information properly. Earlier on I said we need to choose let's choose A to B and write all the information we have between A and B. We can choose A to D also, A to D, and see if we have more information there. Between A and B, initial velocity, we don't know it. Final velocity, right? Initial velocity will be velocity at point A, and final velocity will be the velocity at point F. If this is our initial, this is our final. Initial velocity will be velocity at A, final velocity will be velocity at F. This is the motion of an object. So final velocity is it's 0, because final velocity is at B, and at maximum height velocity is always 0. Acceleration 9.8 meters per second squared downwards always. Now let's check displacement from A to B. Displacement, do we have it? And change in time, do we have the two? Please assist. Please assist. Do we have the velocity at point? Do we have this the position between A and B? What is the position? What is the displacement? What is the value of change in y between A and D? And what is the value of time? Please assist. Let us interact. What is the value? Because we are still collecting data. When you collect data, make sure that you get everything correct. Oh yes, Simanye, the velocity is always zero at the maximum height of an object. That's the only, for an object that has been thrown up, that is the only point the velocity is zero. When you throw an object up, the initial velocity is not zero, and the final velocity where it reaches the ground is not zero. The velocity is only zero at the maximum height, only that part, for an object that has been thrown up. For an object that has been thrown up, velocity is only zero at maximum height. Yes, I see is my helper. You have the time as 0.6 as well as Matsane. Z has time as 0.6, correct? Time is 0.6 to reach maximum height. Excuse me. It's 0.6 seconds. Then what about displacement? Displacement, the displacement between A and B, between this part and this part, which is that part, is not known. We don't have it. So we don't assume it. But 10, remember 10 is not a distance or displacement or position of the ball at maximum height. This is the position of the height of the balcony. This is not the distance traveled by the ball. Nope. It is from A to B. It's not, we don't know that value. And we have two unknowns. Okay, you are allowed to have two. Just don't have more than two. Now let's try to solve this question now. The question 3.4 says 3.4 says calculate the velocity at the initial velocity of the ball. Between A and B, I think we have enough information because we have two unknowns. Two unknowns is fine. So we're looking for initial velocity. Now, it means the next thing that we have to do, we have to choose direction. Which direction do you choose as positive? Do you choose up positive or down positive? I decide to choose up positive. Remember this choice of direction, everyone makes their own choice. Ne? We will mark all the choices correct. I decide to choose up positive, so it means anything that is going down is negative. Now I have to go choose the formula now. Remember what I said earlier on, that when you choose the formula, there are four formulas in the formula sheet. The formulas that we're looking for, they are here. Those that missed the earlier session, we discussed this topic in quite in details, and just that's why we started with questions now. When you choose the formula, you look at everything that you have, and the formula that you're going to choose should contain the thing that you're looking for. You're looking for initial velocity, and try by all means to avoid the other one that you don't have. You don't have displacement, so we'll try by all means to look for a formula that does not contain displacement. Let's see the last formula. The last formula contains displacement. Nope, it's not our choice. The other one contains displacement also. This one contains displacement also here. So these three formulas, nope, they are not our choice. Only the first one does not have what you call displacement. So we choose the first one. It says final velocity equals to initial velocity plus acceleration change in time. And that's how we write it. And remember, we're choosing up positive. Yeah? So now let's substitute all the values in here. So final velocity, it is where the object reaches the maximum height. So this is 0. Initial velocity is what we're looking for. So we just leave it as it is. And the acceleration is downwards. It's 9.8 downwards. We chose up positive, so we substitute this one as negative 9.8. The time it takes to reach maximum height is 0.6 seconds. And we have substituted all the values. Now, making the right choice for formula, you are guaranteed that mark. Then the substitution, all of it will be another mark. Now we have to solve the mess now. So this is 0 equals to VI minus 9.6 multiplied by, so you take out your calculator, you have 9.6, no, not 9.6, 9.8 multiplied by 0.6, 9.8 multiplied by 0.6, okay, it's negative 9.8, excuse me, it's negative 9.8 multiplied by 0.6, you must be getting negative 5.88, negative 5.88. Now the next step, you transpose this number to the other side, or you can transpose VI. Depends which one you choose. I decided to transpose this number because it's negative to make it positive. 5.88 equals to VI. So it means therefore VI is 5.88 meters per second. Now let's go check the question again to see do we need to write direction or not. To see if we need to write the direction. Let's see. The question says calculate initial velocity. So if it says calculate initial velocity, they did not say magnitude, they did not say speed. This physical quantity requires a direction. You only don't write direction when they say calculate magnitude of velocity because that's the size. The word magnitude means the size. So we don't write direction. If they say calculate the speed is a scalar quantity, it does not have direction. But here they just say velocity. Velocity is a vector quantity with direction. Now we chose up positive. Our answer came out nicely as positive. We did not change the sign anyway. It came out as positive. We transpose number positive and we get positive. So it means this is up in the upward direction. And there you get 3 marks. Let's see how your marks are awarded. 1 mark for the correct formula. Remember, we are not making wrong choices of formula. We are not making wrong choices for formula. We must get formulas right always. 1 mark for formula, and then the substitution, all of it is another mark. Then your answer, the numerical value with units, correct units, and the direction, all these 3 things should be there, is another mark. So you get 3 marks for this. Or this was 1 mark, and the definition was 2 marks. 1 mark, 1 mark. So we have solved the question just like that. We've scored ourselves 1 plus 1 plus 2 plus 3. So we scored ourselves 7 marks already. Now let's go to the next question and see how we answer that. I hope we are still together. For those that were in matric last year, okay, this for those for Tshegofatse, this is what grade says what grade is this? This is grade 12 vertical projectile motion. This is grade 12 vertical projectile motion. Yes, I'm sorry, Riho. I was I was somewhere. It's just that you probably did not see my videos, but I did put out some and deleted some. But yes, I was helping grade 12s in most of the Department of Education camps, and as well as in the school where I work. I've always been helping, but I don't think it's late now. You can if you have not if you want to upgrade your marks, you still want to get more marks than what you have, just keep on watching and write in June or December, and you'll do well. I hope you did well also last year. Now let's go to the next question. This says yes, Pumpkin will do a question with air balloon. I have one actually when we are done with this one. Let's now try to solve the next one. 3.5. Calculate maximum height above the ground reached by the ball. So this is what we have. We know the height of the building, right, is 10 meters above the ground. But we don't know the height the ball travels above 10 meters. What we need to do in this case, we calculate the height that reached by the maximum height reached by the ball above this point, and then we'll add this value here, which is something that we did a similar question earlier on, where we needed to calculate maximum height. So we calculate the height from where the object starts, and then we add it to the total height. So let us check how we solve this one. I hope everyone is done. I can remove this and have another paper. If you're not done, just say so, so that we don't leave you behind. Is everyone done? Let me know if you're not done. Let me know if you're not done, so that all right, I believe everyone is following us today. All right, thank you for the feedback. Let us move to the next one. The next question is, I'm keeping this diagram because it will help us solve all the questions here. So I'm just putting the papers slightly down. Calculate the maximum height reached by the maximum height above the ground reached by the ball. So let's calculate the height from this part to that part. Calculate the displacement from this part to that part. Now let's write our information. When you look at the diagram, from the initial part to that part is still A and B. So we still have pretty much the same information, just that now we have the value of velocity. Initial velocity is a value 5.88 meters per second, and it is in upward direction. So it's still the same type of information. We have initial velocity as 5.88 meters per second up. The final velocity at point B is still 0. The acceleration is always, this value does not change, always 9.8 meters per second squared downwards. Remember this all the time. And we don't have velocity. This time we are required to calculate this, and we have the time. So since you only have one unknown, let me write it between A and B. Initial velocity, this is initial point, this is final point. Initial velocity is 5.88 meters per second. Final velocity is not. Acceleration is 9.8 meters per second squared down. Oh, I forgot to write the direction here. This one is up. Initial velocity is in the upward direction. Change in y, or the displacement, is the only thing that we do not know. And then time, we have it as 0.6 seconds. So we have, when you have one unknown, you have many options to solve the question. Any formula will work. Any formula you choose will work. You can choose any of the 4 formulas, because now you have only one unknown. But make sure that the formula that you choose contains that thing that you're looking for. This one does not contain change in y. You cannot use it. This one, that one, and that one, they contain change in y. If you use any of them, you get the correct answer. Let's choose. Let me see, which one do I like to use. I would like to use this one, but you can use this one also, and you can also use this one. Just make sure that you input the directions correctly. So I'm using change in y equals to vi, change in time, plus 1/2 acceleration, change in time squared. I hope I copied it correctly. When you write down formulas, also make sure that you copy the formula correctly, because a formula is a mark. You cannot afford to throw away marks from a formula. So make sure you write down everything correctly. Now let's substitute everything that we have. See, initial velocity is 5.8. Now before we substitute, we forgot to do something. What did we forget? What did we forget? What did we forget, people? We forgot something. Is it nothing is real? You ask, do we do grade 11? Yes, we will do grade 11 topics, the Newton's law, as well as the Coulomb's electrostatics. Those 2 topics, they are fit for grade 11 and 12. They are examined in grade 12 as they are. So even for grade, when we are doing them, all the grade 12 should be in attendance, listening to that part. So yes, we did. Yes, to the 2 gentlemen, we did not write the direction. So we need to choose direction. Which direction do you choose as positive? We chose up on the first one, so I'm keeping up as positive. But you are not forced to choose up as positive. You can choose down positive. Depends on the direction that you would like to make as positive. So 5.88 is up. I take it as positive. 5.88. Time cannot have a direction. That's why I did not write direction next to the time. So 0.6 substituted plus 1/2. The acceleration is down, is in the downward direction. So that one is going to be negative, because it's not in alignment with the direction that I choose as positive. So 9.8, and then multiply everything by the time. The time will still be the same, 0.6 all squared, and time cannot be negative. Now you input all these values in your calculator. Any calculator will take it directly to the answer. So we have 5.88 multiplied by 0.6 then plus 1 over 2 multiplied by negative 9.8, and then multiply this by 0.6 all squared. This gives me, from my side, I have 1.764 meters. Did I miss everything? Did I do everything correctly? Let's see. I have 5.88 multiplied by 0.6 plus 1 over 2 multiplied by negative 9.8. Remember, 9.8 is negative. When you put it in a calculator, remember to put it as negative. Then multiply this by 0.6 all squared. You square 0.6, then you equals to get 1.76. So that's it is in meters. Yes, yeah, it's 1.76. But this is not the answer. This is just the distance between A and B. It's not the distance, the total distance from the ground. So from the ground, we say therefore the height of this will be 1.764 plus you add the height of the building from the ground to the top, from the ground to the point where the ball was unleashed. So plus 10, you add 10 to that, you must get 11.764 meters. And this is how you get your, it's supposed to be, okay, it's 4 marks. This is how you get your 4 marks. 1 mark for the formula. Everything in the substitution is 1 mark. We do not mark that answer because we are using it in the next step. So we give you a mark for adding 10 to the previous answer, and then the final answer. So say for instance you made a mistake, like you did not have 1.764, but you take that answer, you add 10 to it, you're going to be awarded that mark. But you now added 10 to your previous answer. You'll only forfeit the last mark, but at least you'll get. I doubt that you probably, the only mistake that you will have is calculation mistake, but mark for formula substitution and then adding 10, then the final answer. There you have your 4 marks. Let's see the next question now. The next question says, calculate the magnitude of the final velocity of the ball when it reaches the ground. So the velocity at point D. Now, this object goes up, comes down, the velocity when it reaches the ground. So what will be the velocity at point D? Now, now this will not work for us anymore. We need to write down a new set of information. Let's see what we do now. Let us choose between A and D. Between A and D will give you the correct answer. Also, if you solve a question from B to point D, I'm making these points because it makes this question quite simpler. Between B and D, if you write down all your data correctly, this will also give you the correct answer. And also between C and D, you'll get the correct answer. We'll do, let me write between C and D also. So let's collect all the information between these 3 points, between these 3 segments. Which segment would you like to do first? Which segment would you like to do first? The segment that you would like to do first, which segment? Between A and B. 3.5. Let me see. Calculate the maximum height above the ground reached by the ball. Now 3.5, it's not necessarily, it doesn't become a difficult question. It's most of the time a simpler question. It becomes difficult now when you have 2 objects flying in the air, and then they ask you about they ask you questions on how far were the 2 balls from each other when the time was this and that. But as it is now, it always comes like it. We'll do another question, you'll realize that no, there's no way it becomes more difficult than this. So I'm choosing A to D, A to D, A to D. A to D. I hope you focus on this one, with Asante. It's not that difficult. This is not, it's physics. It's not that difficult. Let's choose between point A to D and C. From A, this is my starting point. I said where I start, I'm gonna make a dot for displacement. So let's write down initial velocity at A, final velocity. Always write down all the 5 physical quantities when you want to solve a question and become successful. Write down all the things that you have. Initial, all the physical quantities, displacement, time, and acceleration. This we say it is almost 9.8 meters per second squared down. Now let's put in all the arrows between point A and D if we're choosing to solve a question between point A and D. The initial velocity is the one that we calculated in the previous step, so it's 5.88 meters per second up. The final velocity at D is what we're looking for. Remember, when you choose point A and D, A becomes our initial part and D becomes our final part, our final point. The displacement between A and D, this one is quite a trick one. Let's look at it. Where you start, you put a dot, and then where you end, the object stops here. So it stops a certain meters below the starting points, and we put an arrow where it stops. That's what we said earlier on with displacement, and this will be our displacement downwards. The time, we don't have the time between point A and D. Look at the graph. You don't have the time between this initial point going all the way up to here. We only have time at point T, which is 1.2 seconds. But at the final point there, we don't have time. So we don't assume it, we leave it as it is, as 10, as unknown. Now this already guides us. OT, when we're choosing the formula, we must avoid the formula that contains time, because we don't have time there and we're looking for final velocity. Remember, the question, they did not ask us to calculate time. We were asked to calculate we were asked to calculate the final velocity. They want the magnitude of the final velocity. When the ball reaches the ground. So let's ignore the issue of time and solve the question now. Okay, let me see. I try to fix my network. Let's see. Let me. I'm back again. Thank you. I think the issue of network is sorted out. Is it sorted out on your side? I think I had network problems. I believe you are fine now. Oh yeah, we're still calculating the distance between the two endpoints, point N and not the velocity, final velocity when the object reaches the ground. So we chose up positive for all our situations. So let's keep this one up positive again. I'm trying to keep the same direction that I started with. So we keep up positive, and then let us calculate and see. So final velocity is what you're looking for. We leave it as final velocity squared equals to initial velocity. It's up, and I'm choosing up positive, so this will be 5.88 squared plus 2 multiplied by acceleration. Acceleration is downwards, remember? So it's negative 9.8. Negative 9.8. And then displacement is also downwards, so it's negative 10. I hope you understand why the displacement, we took displacement as downwards. And then from there, what is left is the mass part. Now you do all these numbers on the right from a calculator. Final velocity squared, you do all those numbers. 5.88 squared plus 2 into negative 9.8, then multiply by negative 10. All those numbers should give you a positive number, which is valued at 230.5744. So it's 230.5744. And now this is it squared. This is squared, and then you square it both sides, you get final velocity. Square it both sides will be the square root of this number, final velocity 2.230.5744 equals to, then you square root of this number, then you get 15.18 meters per second. Now we are not going to write direction here. Why are we not going to write the direction? We're not going to write the direction because they say they want the magnitude. They are not just saying velocity. Remember the first question, they did not mention magnitude. So we wrote the direction for this one. For this one, we're not writing the direction. There are two answers, like the square root. Remember the square root gives you plus and minus, né? But we are taking the positive one because they just want the answer, the value of the velocity. And this is the correct value of the velocity. So now let me check. Yes, Fuman, you say, so if we choose upward as positive, our 9.8 will be negative for all our calculations. Yes, correct. If you choose up positive, remember acceleration is downwards, always downwards. Let me check my notes from earlier session. I'm going to cover this for a moment. This value of acceleration is always 9.8 meters per second squared, and this is the value and the units, and the direction is always downwards. So if you choose a positive, that value will be negative. Yes, John Black, Sam. Why is delta y negative? So let's go back to the diagram again. This is the object. I made a drawing again of this. This object goes up, passes point B, passes point C, and then it lands at point D, which is below point A. So the object goes up, comes to C, and then to D. When you measure the displacement, I said earlier on, I'm going to do it because I believe some of you were not in the earlier on session, earlier on. If I have this as point A, I'm just explaining this. I'll show you the calculations again. And then the object lands at point B. It starts at point A, it lands at point B. Let's consider these 2 points. But this object doesn't come straight to A to B. It goes that direction, then goes back, and then lands at point B like that. When you measure the displacement, we always going to measure the object started here, and then stops here. So we measure the displacement as a straight line connecting the 2 points. A straight line connecting the 2 points will be measured like that. But here we make a dot, it starts there, then where it ends, that's your arrow. You can see the direction is pointing from A to B in this case. So let's do another situation like this. So if for an object that moves from point A to point B, and then it lands later on at point C, A, B to C, the displacement, okay, I forgot to write that, the displacement of this object will not be A to B to C. No, it's a straight line between A and C. I did not write C. It's a straight line between A and C, and then where it starts, this is where it starts, and this is where it stops. Where it stops, we put an arrow there, and the direction of the arrow is from A pointing that way. So in our situation here, what we have, this time I doubt the network is mine. Yeah, but let's check. In our situation, we have this object moving from point A to point B to point C to point D. Doesn't matter whether it went up, down, and so forth. But where does it start? It starts at point A. So this is where the object starts. And it stops at point D. Point D is the same height. This stops here. So we draw a straight line from A to D because we are considering line A to D. We draw a straight line from A to D, and the arrow, where we start, we make a dot. Line arrow in the corner, where it stops, where the object lands, it becomes, that's where you put our arrow. Now, can you see the direction of the arrow is pointing from A to D is in the downward direction. The distance, we know the distance is 10 meters, but the direction is going to be in the downward direction, so it becomes down. That's why we wrote delta y is 10 meters downward, and that's it gives us the downward direction. So I believe that answers your question. Let us see, how many marks was this question? This question was It was 3 marks. So it means it's going to be 1 mark for the formula, 1 mark for all this substitution, and 1 mark for the answer. And you have your 3 marks. I believe that this helps in solving this question. Now, do you want to see another way of getting to the same answer, or we are satisfied with this one? Let me quickly check. Is this solution correct, or should you do the same solution using different starting position? Let me see. I don't understand. Please elaborate. Okay. What I'm saying is that the displacement becomes negative because the object starts moving from point A. It lands at point D. So the arrow will be pointing from where it starts to where it stops. This is the beginning. This is where it lands. And that distance is 10 meters above the ground. It's shown here in this diagram. So it starts here, it lands there. The position, remember this is the time. Time is moving that direction, but the position, the object went up and down. So it starts here and it lands at a 0 position there. And this is, the distance is 10 meters, but it is in the downward direction because the distance from where it's moving to where it stops is 10 meters. So the direction will be in the downward direction. That's why we have that as down, the displacement as down. Then we take all the values we substitute. But the value of acceleration is always downwards. If you choose a positive, so it must be negative. That's why this one is also negative. So these two have the same direction. They are both downwards, so they are going to be negative. If you choose up negative, now we choose down negative, meaning we're choosing up positive. So this becomes negative. But if you choose down positive, these two become positive, this one becomes negative. This one inside the bracket, you must substitute negative, and you land at the same answer as everyone else. Anyone who wants to see the same thing using different points, we can do it with different points to check, but we are always going to land with the same answer. We're always going to land with the same answer. If we use B to D, point B to D, point B is this part, and this becomes our initial, this is our final. I'm choosing A to D because it's much easier to solve it like that. But you can choose B to D, you will land with the same answer. Let me just give you the information. If you choose B to D, it means initial velocity, final velocity, displacement, change in time, and acceleration. This is always 9.8 meters per second squared and down. The time to move from B to D we do not have. We still don't have the time. It takes the object to move from this highest point up until where it reaches the ground. So we don't have the time. The displacement of the object is from point this to that point. Now it's no longer 10. It is the displacement we calculated here, the maximum height. So that is 11.764 meters, and it's also in the downward direction because the object starts there. This is the initial part. It lands on the ground, so it starts from this point. We make a dot there. It lands below that point, so we make an arrow there. You see the direction of the displacement. So this becomes your displacement if you start from B to D. So that's why it is no longer 10. It is 11.764, and it is in the downward direction. Final velocity is not known, is what you're looking for. Initial velocity is 0 if you're choosing points B to D. This will give you the same answer as you did now. You'll have to go choose the formula, but when you choose the formula, avoid time. Avoid the formula that has time, because we are not given the time of the object between those 2 points. So this will also, the formula will be the same, the numbers will be different, the direction you keep the same direction, and then it will be correct. Now the question, Yoti Marase, shouldn't you always write direction of object even if you're not asked about the magnitude? Okay, we usually advise that because we know you people forget to write the direction even when you're supposed to write it. But the right way to go about it is when they ask you for magnitude, remember a vector quantity is a physical quantity with both magnitude and direction. If they ask you magnitude, the direction, they don't require direction. They only care about the magnitude, the size of that thing, the numerical value. They don't care about the direction. If they say calculate speed, they also don't want the direction. But if you write direction, you normally don't mark it wrong. Just ignore the direction and mark the answer. But the right way to go about it, you write the direction when they don't say magnitude and they don't say speed. That means they were looking for velocity like they did in 3.4. They just say calculate the initial velocity. They did not say calculate magnitude of initial velocity. So here the direction is required. But on this part, they say magnitude of the final velocity. They want the value only when they say the word magnitude. I believe I answered you there. So if you go about this one, you can solve the same question. This is that will be method 2. I don't think anyone wants to see that. Believe you want to see us moving on. Now the last question. No, it's not the last. Is it the last? Yes, the last question. Now the last question is, it says draw a velocity versus time graph for the motion of the ball. Indicate the following on your graph: initial velocity, final velocity, time taken to reach maximum height, and you are awarded for marks for doing that. Remember what we said about velocity time graph. Velocity time graph, let me remind those that did not join us earlier on. There are two formulas that are very useful here in the set of all the formulas. The first formula and formula number 3. The first formula gives us the velocity time graph. It is in the form y is equals to c plus mx. If you look at the maths graph, it's in the form y equals to c plus mx. So the initial velocity is your c point, is your y-intercept. This is your slope, and this is your x, the values on the x. This is your values on the y. And this formula gives you the displacement time graphs. Because it is a time squared factor, that's why it becomes a parabola, almost like a parabola, but we look at one part of the motion. So whenever they want a velocity time graph, I advise you to draw it's going to be a straight line, but let's write down everything that we have. It's normally we use the things that we have. So our graph, first of all, you must have your graph. You don't want a space, you don't want to see drawing it up to scale, but you want to see it numbers. Lie its time in seconds and lie its velocity in meters per second. And this is the velocity versus time graph. And now we have 0 for all the points at 0. So this side is negative velocity, this side is positive velocity. Now all this time we've been choosing up positive, so let's keep the same direction as positive. So up positive. If it's up positive, your graph is a straight line that goes like that. So it starts this side, it goes that way. But now let's do it step by step and see. What is the initial velocity, or the velocity when the time is 0? The velocity at this point. We found that it was 5.88. So it's 5.88 is a point somewhere there. It's 5.88. Now notice that I'm taking it as positive because the initial velocity is going up. When the object is going up, the initial velocity is going up. And we are choosing up as positive. So that is the value there. Now, the points that are important when you draw the graph on the motion is the point there, the point there, the point there. 1, 2, 3. Those are the important points. You can consider point C if you like, but it's not that much important. Point at A, points at B, points at C. The coordinates. When the time is 0, initial velocity is 5.88. When the time is some value 0.6, velocity is 0. So when the time is 0.6, somewhere here, x value is 0.6, velocity is 0. X is 0.6, velocity is 0. Now, at some point, the velocity is negative 5.88 and the time is 1.22 there, but we are not interested in that. We're interested in the final part because that's what the examiner wants to see. He wants to see the initial velocity, final velocity, and the time taken to reach maximum height. So this is 0.6. And the last part will be the um, the all right, the last part will be the velocity of the object when it reaches the ground. It's the value that we calculated not long from now. It's 15.18, but this is very misleading because we chose a positive. This value is supposed to be negative in the right direction, but because they wanted magnitude, this value is negative 15.18 because it's going downward. So it's 15.18 and the direction of this thing is downward. So it's going to be a value somewhere there, maybe somewhere there. When the time, it's a value that we don't know because we did not calculate that time. The value of the velocity, is negative 15.18. So this is a straight line. The straight line moving from that part passing through the x-axis, and there we have it. This is the velocity time graph that they're looking for. We have all the points they say you must show. We get 4 marks. Number 1, you get a mark for the shape. You get a mark for shape, 1 mark for shape. Shape of the graph is 1 mark. Now showing all these points is a mark. And there you have it. This is the graph that they want. I said to the people that I was with earlier on when we were doing this session, I showed them the notes that the velocity time graph is always a straight line that crosses the x-axis going down or crosses the x-axis going up, depending on the direction that you choose as positive. So we chose a positive, the line goes down. It passes through the x-axis. This is the velocity at maximum height. So always this part is maximum height. This is when it reaches the ground, and this is the initial part. The other thing that we mentioned earlier on, we discussed was the slope of this graph. The slope of the velocity time graph. So let's say the slope or the gradient. We can say slope or gradient of the velocity time graph equals to acceleration. And the acceleration of this object is 9.8 meters per second squared downwards. So always the velocity time graph gives you two things. It gives you the slope, which is the slope is the acceleration, and then the area under the graph. Under the graph, the area under the graph is the displacement. This is quite interesting. The area 1, let's say this is area 1, this part of the area will be the displacement of the object as it moves up. So if we look at it, as the object goes up, this is the area because this is the positive area and we're choosing a positive. So this is the displacement area number 1. Then area of the second graph, the second part, this part, area number 2, will be the displacement from the maximum height up until the object reaches the ground. So this one is positive. Remember, it's positive. This one will be negative because you're choosing up positive, down negative. So keep that in mind when you're doing this regarding the issue of area, displacement, time graph. I hope that we managed to hit two birds with one stone. So just keep it in mind that the area under the velocity time graph is displacement. The gradient of the velocity time graph is acceleration. You'll find questions like that in the test. Any question? Should we move on? Any question? Yes, you say you need help. We are here to help. That's why we are here. We are here to help you. um um yeah, we are here to help. I think this is fine. i'll I'll upload the video where we discuss this topic on YouTube, and you can check it there. You can check the whole explanation of the graphs, and you can repeat it many times. I'll upload it. Just be on the lookout to this week. I'll upload the session where we discuss this thing. I'll also upload the video that I'll upload both the videos, the one that we discussed, the one that we the live video for earlier session. I'll upload it also on YouTube. Please be on the lookout for it. And the link to my YouTube channel, it's the same handle I have on TikTok. It's the same handle for YouTube as well. Or you can go to my profile. There's a button there where you just click. There's a button that looks like this. It takes you directly to my YouTube account. If you press it, it takes you directly to my YouTube account. Now let's do one more question and see if we are understanding. This one we are fine with it. Before we do, let me check the next question. How will it look like? I'm trying to see a hot air balloon problem, or someone requested hot air balloon. Let me check if I have it here. I thought I had it. Let me check. All right, here we have it. We have one, but this one, the hot air balloon, I think it's moving down. Yeah, this one is moving down, but it's fine. It's okay. It's not the method to solving questions on hot air balloons are the same. All the method to solving hot air balloons the same. Now let's look at this one and check all the important okay. Colisi is requesting question for 2 balls. I have one. I'm just not sure that we will have enough time to to reach to do that question, but I have one here. Let me check. I have this one. I also have this one. I think I have 3 of them. Yeah, and I also have this one. So let's check. Let's finish the other one first, the hot air balloon, and then try to finish that one and see what happens when the objects are 2. When you have 2 projectiles, but now we have only one. We have the hot air balloon. Normally, when we have a hot air balloon and an object is dropped from it, just keep this in mind and write it down and note it very well. The initial velocity of the object that is thrown out of the hot air balloon will be the same as the velocity of the hot air balloon. So if the hot air balloon is moving up at 10 meters per second and an object is dropped from it, that object won't go down straight. To our eyes, it looks as if it goes down straight, but it does not make sense. It starts by moving up a little bit with the initial velocity equals to the initial velocity of the hot air balloon most of the time, because the hot air balloon is not in free fall. It is being kept up there by the warm air inside the balloon. The thing that is dropped now becomes in free fall. So keep that in mind. Keep that in mind all the time. The initial velocity of a projectile that is thrown out of the hot air balloon is that one of the hot air balloon, if it's just dropped. Then if it is thrown, then that's when we have a different scenario. We'll deal with situations like that when we come across it. Now let's analyze this one. Let's analyze this question first. They say a hot air balloon moves vertically downward at a constant velocity of 1.2. So already the first statement, this one is already telling you that the hot air balloon is not in free fall, because when an object is moving at constant velocity, it means the acceleration of that object is zero. So the acceleration of the hot air balloon is zero. It is moving at the speed. So, but this does not impact the projectile that will be thrown out of the object. I mean, out of the hot air balloon. Let's quickly read further. So this statement is very important. The hot air balloon is not what we're interested in. We're interested on the object that is dropped from the hot air balloon. When it reaches a height of 22 meters from the ground, a ball is dropped. So now this is where it becomes more interesting. A ball is dropped from the hot air balloon. A ball is dropped from the hot air balloon. Refer to the diagram below, and you can see the diagram. Above 22 meters above the ground, this object is dropped. It lands to the ground. The speed of the hot air balloon is 1.2 meters per second, and it's the same constant speed. The velocity of this thing does not change. When this object is dropped, notice in this case, the velocity of the object, initial velocity of the object is not zero. Initial velocity of the object becomes 1.2 meters per second down. Because it is dropped, its initial velocity is supposed to be zero, but it is inside a moving object. So it assumes the speed of the hot air balloon. This projectile assumes the speed of the hot air balloon. So its initial velocity is that one of the hot air balloon. Now it says that the statement continues further down to say, assume that the dropping of the ball has no effect on the speed of the hot air balloon. Ignore air friction for the motion of the ball. So we are interested in the ball. Explain 3.1, the term projectile motion. Yeah. Now, I said earlier on to the group that I was discussing with that the word projectile motion equates to some weight. But please define it and write your answer yes above here. Define the term projectile motion. And then we'll answer that one. Yes, we'll entertain all these questions. They are quite interesting. Let's see how we answer the first one. Goli says an object upon which the only force acting is a force of gravity, and the other one says is motion where the only force acting on the object is gravitational force. So we're missing the word gravitational force there. It's gravitational force. So yes, these are two different definitions. So which one is it? I hope we all wrote our answers somewhere. Let's check. Earlier on in our discussion, this is what we had. We said the definition in this chapter, there are only two definitions that you need to remember. One is free fall, the other one is projectile. And we said projectile is an object. That's why the first word that we start with there says object. That is projectile. It's projectile. And then free fall, it's motion. The first word we have there, it's motion. Keep these keywords. Motion of an object. This is just the object. And we refer to free fall. We said sometimes the examiner will not use the word free fall, but use the word projectile motion. So when they say projectile motion, they are saying a different thing from projectile. So projectile motion, it's free fall. It's actually this equates to free fall. Projectile motion is exactly equivalent to free fall. So the correct answer will be motion of an object for which the only force acting is gravitational force. And in the earlier on, I said that if you just memorize the definition for free fall, the difference between the two, it's actually in the first definition from here, you actually see that it's the second definition. The highlighted part, you notice that these two are exactly the same. So free fall is motion of an object. The only difference from free fall and projectile will be those first three words. But keep it in check all the time. Revise it, practice it many times so that you don't forget. And also remember that projectile motion is equivalent to free fall. But projectile, this is a different thing. This is just an object. But projectile motion is the motion. They're talking about motion here, is the motion of the object that they're referring to. So the correct answer here will be this one, the definition for free fall. So this is motion of an object upon which the only force acting is gravitational force. It's motion of an object. So it will be that one from visit. I don't know how to pronounce your name, but yes, it's VUODEYI. So that one, the definition will take that one. But it's quite tricky, obvious, when the examiner decides to use the word projectile motion instead of free fall. I understand it's quite tricky sometimes. Don't lose marks. We're not losing these marks. Definitions, nope. You're not losing all the marks. Remember, every question has one definition, at least one. So you must get all that, all those marks from definition. Now 3.2, they say, is the hot air balloon in free fall? Is the hot air balloon in free fall? Is it in free fall? Is the hot air balloon in free fall? Let's think about it. And please submit your answers. Hoti says the hot air balloon is not in free fall. 3.2. Hoti says the hot air balloon is not in free fall. Cindy agrees that the hot air balloon is not in free fall. Piso also agrees. Yes, I see. No, most of you are saying it's not in free fall, but give the reason. Then let's continue. Give the reason for your answer. Why is it not in free fall? I agree with you. The hot air balloon is not in free fall. The answer is no. Correct? No. Give a reason for the answer. Why is it not in free fall? Why is it not in free fall? Why is it not in free fall? Say, viewer says no because its velocity is constant. Leah says no, it is its own initial velocity and then gravitational force acts then on it. Isn't in free fall because Hoti says isn't in free fall because it is moving at constant velocity downward, meaning acceleration is zero. No, because VI is equals to velocity of the hot air balloon. Yes, they're talking about the hot air balloon. Let's see. The reason is because there's more than one force acting on an object. Remember, for an object to be in free fall, it says there was the word only. Yes, there's a key word here. Only. The only force acting on it is gravitational force. When it says the only force acting on an object is gravitational force, it means that F net equals to Fg. That's what it means. For an object to be in free fall, it means F net equals to Fg, and that means F net equals to mg. When the object, for an object to be in free fall, this is what is meant. But in this one, F net is 0. F net is actually 0 because F net is ma, but a is 0 because the velocity of the object is constant. So this is m, F net is 0. So there's many of reasons that you can give. For those that says velocity is constant, correct? The velocity of the object must increase as the object comes down. If it does not increase, it's because the only force acting is not gravitational force, then velocity is constant, then that's nope, that object is not in free fall. For those that say velocity is constant, correct, and for those that says F net is 0. That is also correct. And if you also wrote acceleration is 0, you will be correct. Any of the three options will be marked correct. If you say velocity is constant, you will get a mark. If you say the net force is 0, you get a mark. If you say acceleration is 0, you get a mark. Also, if you write there's more than one force acting on an object, there's more than Fg, there's more than one force acting on an object. Remember, for object to be in free fall, there's only one force acting on an object, and that is Fg. So if you say there's more than one force acting on an object, you'll be correct. Yes, so that will be there's more than one options there. Let's look at 3.3 now. 3.3 3.6, calculate the time it takes for the ball to hit the ground after it is dropped. So the object lives here. So where it starts, I would like to choose that as A always. Make that point A, and then there's no any other thing happening between. It comes straight down to B. So when it reaches the ground is B. So it means we need to write down information now. Let's write down information C. So it means we have between A to B, we have VI of the object. The velocity of the object is equivalent to that one of the hot air balloon. When we have a hot air balloon situation, the focus is not the hot air balloon. The focus is the object that is dropped from the hot air balloon. Keep that in mind. Ne? So the velocity of the object is equivalent to that one because it is dropped 1 meters per second downwards, because the hot air balloon is going down, so that the direction will be also downwards. Final velocity when it reaches the ground, we don't know it. The distance it travels from the time it is dropped is 22 meters. The distance it travels from the time it is dropped. The time it takes to reach the ground, do we have that? Let's read in the statements. I don't think we have that. And the acceleration, is always 9,8 meters per second squared. Always 9,8 meters per second squared. Always 9,8 meters per second squared downwards. Does not change this. This is always given. You'll never be asked to calculate that. It's always given, unless you're given a graph and then you're asked to calculate it on the graph just to prove it is 9,8. But in normal calculations, nope. You will always be asked to calculate any of the four. So that's why I always write all 5 physical quantities. This one is always given, and see what is it that we have between the 2 points. Now the question wants us to calculate the calculate the time it takes for the ball to reach the ground. So we're looking for the time, and this we don't have. So it means we are going to go to search for a formula to avoid this thing. If we don't have it, it's going to make our life very complex. Look for a formula that will take you straight to the answer. So let's look at the formula sheet. Here's the formula sheet now. Where's the formula sheet? Oh, here it is. So from the formula sheet, we choose a formula that does not have final velocity. We are avoiding final velocity. Yes, yes, Hoti, I made a mistake. The time is what you're looking for. Let us see now. Which formula has no? We are looking for time. We are trying to avoid. What are we avoiding? Final velocity. This one has final velocity and time. We are avoiding that one. Final velocity, no time. Nope. No final velocity, but time. So this is the formula that we are choosing. This one has time and final velocity. Nope. So we're choosing the third formula. So the formula says V final squared equals to V initial squared plus acceleration change in time. There we have it. No, this one. This is the wrong formula. It should say change in Y equals to VI change in time plus 1 over 2 acceleration change in time squared. And this was incorrect. Make sure when you copy the formula, you copy the right formula and correct formula. we are avoiding final velocity. That's why this one is wrong, and light did not write it correct. So the correct one is this one. Now the next thing that you must do, you must choose direction, whether you choose up positive, down positive. But in this case, the object did not go up, it just went down straight. So let's choose where it decided to go first as positive, and then we can substitute everything. So delta y is 22 meters. We did not write the direction here, but let's do it again. The object starts here, it comes straight down to point B. So you can see the direction of the displacement. This is displacement. The object starts where the object starts, you make a dot, and then where it stops, you put your arrow there. You can see where the arrow is pointing. So this is your displacement. It's downwards. So it's down. So this must be 22. We're choosing down positive. 22 equals to VI is 1.2 because it's down also positive. The time is not known. Plus 1 over 2. Acceleration is down, so it's just positive 9.8, and the time is 1.2 squared. I think that helps us enough. So now let's see, let's work out the solution. No, I made a mistake. This isn't correct. I see now. Time, we don't have time. This is still remaining time. Forgive me for this. Still changing time squared. We don't have time. So if you don't have time here, you cannot have time there. 1.2 is initial velocity. I hope you saw that it is a mistake. Now we don't have time here, and we don't have time squared here. We will not be able to solve this unless you are able to factorize. If you can factorize this, then we'll be fine. But now let's try to see. This will be 22 equals to 1.2 change in time. Half of 9.8 is 4.9. Change in time squared. And we can't solve this, we can't factorize this, we can't factor out t because we don't have 0 this side. So let's transpose 22 to the other side to get 0 equals to negative 22 plus 1.2 change in time plus 4.9 change in time. So I'm going to do it step by step so that everyone understands what we did. You'll bear with us if but you are allowed to obviously move faster than us and apply your maths. But I'm going to do step by step so that everyone is able to score the marks up until the last part. Now the next step, there's unknown, no unknown here. So let's rearrange this from this one. So I'll start with 4.9 t squared, or change in time squared, plus 1.2 change in time minus 22. It is equals to 0, but I can write equals to 0 this side because this is a pen. If you put it like this, it's still a pen. So we have this. Now we apply quadratic formula to solve this. Remember, quadratic formula says that now we don't have change in x. We don't have x now. We have t. So it says t is equals to minus b plus minus the square root of b squared plus minus 4ac. Divide everything by 2a. And you put this in this is b, not 6b. You put this in a calculator. First you put it to the plus, then you come secondly put it to the minus. So let's see. In a calculator you're going to substitute minus b. So if we have it like this, you started with the high order, the highest degree, you come with the lower degree and then to one without the square. This becomes your a. The number before t squared is a. The number, this becomes your a, this becomes your b, and this becomes your c together with their signs. So the a will be 4.9, b will be 1.2, and c will be negative 22. Those are the things you want to put on all those variables that you see there. So now we will have OA. I'm going to write it here. OA, so that you see, is 4.9. B is 1.2. C is negative 22. So we just take these values, put them into this quadratic formula. Let's see. Minus b is going to be minus 1.2. Negative comes from the formula. Ne? This thing is not given. This quadratic formula is not given. Go physics. You have to remember it from maths. Just practice it. Go maths a lot. You'll be fine. Plus minus the square root of b squared will be b is 4.9. No, b squared is 1.2. 1.2 squared. Minus 4. A is 4.9. 4.9. And then C is negative 22 minus 22. And this works out nicely, so that we have negative data that will multiply with that one. The square root works. It's not a complex number. 2 multiplied by x a is going to be 4.9. And this calculator takes you straight to the answer. You'll get two answers. Let's see what are the two answers that you get. Yeah, for those that think positive upward is always easy, yes, you are welcome to do that. I have 3 classes in grade 12. One of the classes that I teach, students prefer to have up positive all the time. They that's how they want to solve their question. They don't want to think too much about direction. They just choose always up positive. It's fine. It works out nicely if they don't make mistakes. I'm fine. I'm comfortable with that. So let's substitute and those that have the answer, they probably ahead of me. 1.2 negative 1.2 plus. The first time I'm going to put plus, né? The square root of b squared is going to be 1.2 squared minus 4 into brackets 4.9 close bracket, open another bracket, negative 22 close bracket, and then divide by everything, divide by 2 multiplied by 4.9. When I put plus phakathi kwazo, I get t equals to 2, or t equals to, when I put negative between the two numbers, I think I'm going to get a negative number, minus, I get negative 2.24, and this negative, the time cannot be negative. This is incorrect. We ignore it. We take this one 2 seconds. I don't know if I think I took a longer route to solve this, but yeah, whichever way you get to the answer, it's okay. And the time is 2. For those that have 2, yes, correct. We have the time is 2. Celia gets 2, Hoti gets 2, and yeah. Is it Green Lady? No, this is not mathematics. This is physical sciences. But obviously, you need to apply your math skills or physical science. But this is physical science. Grade 12 physical science is vertical projectile motion. Yes, people that agree that once you write down your data carefully, it becomes easy to solve a question. Now you just go and pick up a formula and solve, and you are good to go. So this is how you get, is how many marks was the question? Calculated time, it was 4 marks. So you get a mark. Let's see, you get a mark for writing down the formula, for substituting everything on the right correct, for substituting the value on the left correct, and then doing all this mess until you get to the correct answer, only 1 mark. So yeah, that's how it works. In physical science, we award more marks on analysis of the question. If you substitute correctly, that you'll get correct. Is it Temba? Sorry, man. Now in grade 12, probably I was in grade 12. Now, or I was still at varsity, or probably I was working elsewhere. This was before probably the technology that we have now. This answers the question in 3.3. This is 3.3. Now 3.4, let's see 3.4. What do we want? 3.4. I'm gonna move it up a bit so that I keep this on the screen. Yes, 3.4. 3.4, they say calculate how high. No, there's a statement before that. They say when the ball lands on the ground, it is in contact with the ground for 0.3 seconds, and then it bounces vertically upward with a speed of 15 meters per second. So it bounces up. When it leaves the ground, with this speed. So this becomes the initial velocity if you consider a second part of motion. But if you consider the first part, let's see what they want in the next part. They say, calculate how high the balloon is from the ground when the ball reaches its maximum height after the first bounce. So it means you must calculate the time it takes for the ball to reach its maximum height, and then you calculate and use that time to substitute to calculate the height of the hot air balloon. So now we are that's why there's a lot of marks. We are doing two parts for the calculation because they want information about the hot air balloon, but they give you information about they give you the ball's information, but they want you to calculate something about the hot air balloon. So let's use the ball's information to solve this question. Yeah. So I believe everyone is done with this part. Please follow the account and please go subscribe on my YouTube. That's why I'll be posting more videos, the longer versions of the videos we discuss, because I don't think we'll have time to do lives all the time. Sometimes you will need to check my YouTube channel and then you follow the topic there. I'm going to hide this part and do the next one. Now on the next part, we need to know that the ball comes down, the ball comes down, it hits the ground, then it is in contact with the ground for some time, it bounces up and reaches some maximum height there. So the velocity when the ball, this is when the ball is coming down, this is when it is moving up. So if this were to do displacement time graph, I think something like that, yes. Position time graph. It hits the ground and then it is in contact with the ground. So the distance, this time here, this part will be 0.3. The velocity here, which is VI, will be 15 meters per second up. And the velocity here, maximum height, because they talked about maximum height of the ball, always maximum height, velocity is 0. Always at maximum height, the velocity of the object is 0. Yes, to underline key points on the question paper, you are permitted to do. If you feel underlining doesn't help you, you can have highlighters. Yes, you can have highlighters and highlight your important parts, but you can also have underline. Take your pencil to underline the keywords. So now I'm underlining. You see, I'm underlining maximum height. The only thing that you're not allowed to do in an exam is writing answers on the exam paper, but just underlining per line, no, it's not a problem. Doing this, what I've done here, writing these answers here, you're not allowed to do that. Doing your sketches on the diagram of the question paper, you're not allowed to do that, because obviously, yes, you are afraid with it. After you've done your drawings, you'll pass it to your friend when the invigilator is not looking. So VI is 15 meters per second. V final is not. The time it takes the object to move from this part is not known. To its maximum height is not known. For the second part, we don't know the time it takes to, after it has bounced to reach maximum height, we don't know the time. We also don't know how high it gets, but we know the acceleration. This one we know. We always know acceleration, and this is up. So we have our information of the bounce. Once it bounces, we have all these things. Now we have information collected, right? You are allowed to have 2 unknowns. What you are not allowed is to have 3 unknowns. When you have 2 unknowns, yes, you can calculate. Now let's see which one is going to be more important. Which one will help us to answer the question that they want? Is it the time, or is it the time, or is it the displacement? If you calculate this displacement, you will only know how high the object went. But that will not help us to calculate anything on the movement of the balloon, hot air balloon. What we need to know is we need to calculate this one, the time. If you know how many minutes, how many seconds it took the ball to move from the ground to its maximum height, we can use the time to calculate the movement of the the what do you call the movement of the hot air balloon up until it reaches a specific height. But now let's start with the time here. I believe that that's the first part. So let's ignore if anything that has height, any formula that has height, and the formula that will help us is this one: v final equals to v initial plus acceleration change in time. We choose the formula from the formula sheet always. We ignore the formula that has displacement. All the other threes that I've ignored, they contain a change in y. So I'm ignoring them. This is the only one without change in y. We cannot we cannot use a formula that has two unknowns, or else we will not solve anything. Yes, nope, you can change your direction at any point. You don't have to keep it. If you choose down positive in the previous one and you want to change later on, now I'm choosing up positive, you can choose it. You can choose, as a matter of fact, I'm choosing up positive here. And let's solve now. So it means this one will be positive, this will be negative. So let us see. Final velocity is not, initial velocity is 15 positive plus acceleration is negative 9.8, and I can find time. I think this, I believe this is what we are in the right direction. Let's see. So you calculate time, you find it's vi change in time plus 1 over 2 acceleration change in time squared. Now, the information we have here is of the balloon. The acceleration of the balloon is not 9,8 meters per second squared. Nope. The displacement of the balloon, we don't know how far it went, but you know it was 22 meters above the ground. The total time traveled by the balloon is 3.831 seconds. The initial velocity is 1.2. Initial velocity 1.2 meters per second down. The final velocity is also 1.2 meters per second down, because remember it is maintaining the same velocity, this thing. So let's substitute all the values for the balloon in this formula now. So delta y, the balloon would have traveled a distance equals to, the initial velocity is 1.2 and the time for which it was in motion is 3.831 plus 1 over 2, acceleration is 0, the time is 3.831 squared. This part disappears and we're only left with this part. Then we have 1.2 multiplied by 3.831, and this gives you 4.5972 meters. So it's roughly 4.60 meters. Yes, I noted that at some point I lost you guys there. All right, it's off again. I believe the battery is off. Let's do it without microphone. I hope I'm audible enough. Remember the last question. I'm going to start the whole question, the last question, the whole question afresh for 6 marks. They want you to calculate the distance above the ground, or the height above the ground of the hot air balloon. But keep in mind that the hot air balloon is moving at constant speed. The hot air balloon is moving at constant speed of 1.2 meters per second. So the acceleration of the hot air balloon is 0. That's what you need to keep in mind. But now, the ball, it traveled from the time the ball left the hot air balloon, it traveled for 2 seconds, it reached the ground, it bounced, it hit the ground for 0.3 seconds, and then bounced and reached a maximum height. So they want, from the time the ball left the hot air balloon, it bounces and reaches maximum height, which is this diagram. The ball left hot air balloon, reaches the ground, bounces, it is in contact with the ground for 0.3 seconds. Then it bounces and it goes up. So we know the time from the time it left the hot air balloon up until this part. This part is 2 seconds and then plus 0.2 seconds, 0.3 seconds. So we know the time total, but we don't know the time we don't know the time of the ball in the air from the time it bounced up. It bounced from the surface of the ground until it reached maximum height. So the first part, we calculate the time it takes the ball to leave the ground up until it reaches maximum height. So it bounces here with a velocity of 15 meters per second, and then it reaches maximum height where the velocity of the object is 0. So the velocity of the object at maximum height is 0, and when it bounces, it's 15 meters per second. That part I believe you have it. So this part we're calculating the time it takes the ball to bounce, from the time it bounced to the time it reaches maximum height. So that is the final velocity of the object is 0. This is the data we collected. The initial velocity was 15 meters per second. Then the time it took is not known, and the distance above the ground is also not known. So we have all this information. Now we go look for the formula. We avoid this because we don't have it, and we're looking for total, just the time. So we calculate the time, and the time we have is 0.3 seconds. So this is the time we have 0.1, no, it's 1.53 seconds, excuse me, 1.53 seconds. Now, remember all this time, from the time the ball left the hot air balloon was traveling downwards. All this time, the 2 seconds plus the 0.3 and the other time it took. So the time from figure this is 2 seconds, then this is 2 seconds plus 0.3 plus the other time it for move from here is 1.531. This is total time, all of it. Of the ball has been in motion or away from the balloon for 3.831 seconds. But all this time the hot air balloon has been moving down. So now we have the total time for which the ball has been in air and in contact with the ground and so forth. Now we write down, this is just the time we want to use it here for the hot air balloon. This information is the information of the hot air balloon. The acceleration of the hot air balloon, we agree that is 0, right? Because it is moving, the hot air balloon is moving at constant speed of 1.2. So its acceleration is 0. The displacement traveled by the hot air balloon is not known. We leave it as unknown. The time for which the hot air balloon was in air is 3.831, which is this time that we have from the time the ball left the hot air balloon. So it's 3.831 seconds. And the initial velocity of the hot air balloon is 1.2 meters per second. The final velocity of the hot air balloon is still 1.2 meters per second, because this is constant and this is in the downward direction. It's been coming down, this hot air balloon. Are we still together there before we go to calculations? Are we still together? Now, from here, we have, this is the information we have. This information is the information of the hot air balloon. Notice now, the acceleration is not 9.8 here, because the hot air balloon is not in free fall. So we have this as 0. Now we go and look for the formula now that will help us calculate delta y. But in all these things, we search the formula. This one will not help us because this part disappears. Acceleration is 0, it goes away. We will have final velocity equals to initial velocity. This one will also give us the same thing that this one gave us. When you put acceleration 0 there, this part disappears. We will have final velocity equals to initial velocity. So these two formulas will not help us. The last two formulas will help us, because this one, it has displacement equals to initial velocity, for which we have as 1.2. And the time for which the hot air balloon was in air is 3.831. We have it. This part, it does not matter what you have. We know acceleration is 0, so it will make this part disappear. So I chose this formula, but you can choose this one also. It will work out the same way. It will work out the same way. So we have this. We choose the right formula. We substitute the value, all the values that we have. The initial velocity is 1.2. The time is 3.831 seconds plus 1/2. The acceleration is 0 now. I'm making emphasis now because it's the hot air balloon. It's not an object that is in free fall. And the time is still 8.3831 seconds. And then you put all these numbers in the calculator, it will give you this answer. And this is your answer. This is the answer that, no, this is not the answer that they're looking for. They're looking above the ground. This is the distance traveled by the hot air balloon. So we still need to work it out and calculate above the ground. So above the ground, it will be 22 meters, subtract this part. So it will be above the ground, height above the ground will be 22 meters minus 4.60. I'll go back and discuss the issue of time again, yes. And then we subtract these two, you get, is it 17.4 seconds, 17.4 meters. I believe it's 17.4 meters. Now let's go back and discuss the issue of time. Let me get a new paper, a fresh paper, and write all these things now, so that they understand the issue of time. The numbers, I see the numbers won't be a problem. The problem will be with the conceptualization of the times. Why do we have total time as 8.31? The object, this is the ball at point A. It leaves the hot air balloon. It moves down. It hits the ground. So from the time it left the hot air balloon, this was 0, to the time it hits the ground, this takes 2 seconds. We agree that. We have calculated this in the previous question, I think, here. Go 3.3. Go to the ball travels from between point A and point B. It takes 2 seconds for the ball to reach the ground. This is the time we've calculated here. 2 seconds. It reaches the ground 2 seconds later. So we have it. Now this ball is in contact. This ball is in contact with the ground for 0.3 seconds. So it means the time here will be 2.3 seconds, because this part here is 0.3. The ball is in contact with the ground for 0.3 seconds. This is what is said in the statement. When the ball lands on the ground, it is in contact with the ground for 0.3 seconds, and then it bounces vertically upwards with the speed of this. So it is in contact. This is the ball in contact with the ground. The ball and the ground are in contact. I'm just putting the timeline issues here. Then the ball bounces up here. So this ball was coming down. This is the displacement. I'm trying to do the displacement time graph of this object. The displacement time graph will look like it comes down. It is in contact with the ground for 0.3 seconds. It leaves the ground. Yes, this will be displacement change in y, and this is 22 meters. It leaves the ground with a speed of 15 meters per second. It goes up again, and then it reaches maximum height. And now this is the time that we don't know. The time from this part when it bounces up until it reaches maximum height. But we know on the displacement time graph, there's information that you can write. We know the velocity here is 0. We know the velocity here, which is the initial part of the velocity, is 15 meters per second up. 15 meters per second up. But we don't know the time between the two parts. Changing the time it takes to leave the ground until it reaches maximum height. We don't know the time, because this question lies, question 3.4, it's about time. We need to get the issues of time and use the time in the next part. So we calculate, this is 2.3, and then we calculate the time here, which is what we did over here, which is what we did over there. The ball leaves the ground with a speed of 15 meters per second up. It reaches maximum height, so the speed there is 0. The acceleration is 9.8. The time is not known. The height it traveled for the second part is not known, so we also leave it as unknown. And now we leave it as unknown like that, because we have a choice. We can avoid a formula that contains displacement and use this one to calculate the time then from this part to this part. So from this part to this part, we can calculate the time. And this is what we did here. We found that the time was 1.531 seconds. So it means the time the ball left the hot air balloon hits the ground, 2 seconds, plus 0.3 in contact with the ground, 2.3, plus 1.53 till this part is 3.831. So we have time here 3.831, which is what I did here. I added all the values to get 3.831. Yes, I rounded off the answer line. It was 8.38 is 1.5306, I believe. 1.53, later was 1.5306 and other numbers. So I rounded off the number, that's why I have 1.531. So this is the total time traveled by for which the ball has been away from the hot air balloon. So during this time, the hot air balloon has been traveling down, has been coming down at the same speed. Now we want to know how far the hot air balloon has been now. So we calculate now the displacement of the hot air balloon. The speed of the hot air balloon initial speed is 1.2, and the total time it has been in motion is is this total time. Now acceleration, keeping in mind that the acceleration is 0. The acceleration of the hot air balloon is 0. When the acceleration is 0, what is meant by that is the hot air balloon is traveling at constant speed, so its acceleration is 0. So you work out the answer there, and then you get this, and this is the answer you get. But this is not the final answer. You need to subtract this value. This is the distance traveled by the hot air balloon. The question they are asking is how high above the ground. So you subtract that number from 22, you get 17.4. I think that is giving you the answer. Now I rounded off the number is 4.597 other numbers, but I believe my answer lies influenced by this number because I rounded it up. But let's do it without rounding up and see what we get finally. If we do it without rounding up, we'll get plus 2 plus 0.3. This multiplied by 1.2. Yeah, the final answer will still be 4.5967. So these numbers after this, all of them, they are more than 5. So we round up to 4.60. Yes, I did round up the answer. Round off the answer to 2 decimal place. Let's make it 40. So that's how this question was supposed to be calculated. It's a difficult question, but you cannot get 0. At least what you know, try to utilize what you know. At least these 2 marks you should get. 2 marks for that part. 1 mark for this formula and substitution. You should get that mark. You should be able to get those marks. The second part from there, I know it's going to be messy and there's a lot of steps, and you can get it. It's easy to miss it, but you'll get a mark for that formula substitution, the whole substitution, this and that one, and that's how you get your 6 marks. I believe that helps solving this one, the last question for 6 marks. This was quite a difficult question, but it's a supplementary exam, so it's understandable. I want to do next time when you meet, because right now I don't have time anymore. I want to do a question where we have actually not one question. I think I'll do 2 or more. I'll do a question that that has 2 projectiles. 2 projectiles, both of them thrown up. I'll do a question like that. But for now, tonight, let us stop it here. Go through it and analyze it and check it up, and just solve more questions. The trick with this chapter is know your definitions. That's why you score easy marks. Know how to collect data, and choose the correct formula. So first of all, collect data, choose the correct formula. Those are free marks. Formula marks are free marks. So don't make a mistake there. And the next thing is in your substitution. Once you write down your data correctly, you definitely will not lose marks in the substitution. So that's what makes this topic easy. But remember the direction: up positive, down negative, or down positive, up negative. Make a choice. Decide on the direction. Check out my YouTube channel. I think I'm working on uploading more videos on YouTube, because YouTube does allow us to have longer videos, so we explain everything. And please subscribe on my YouTube and like those videos there for more content. I'll see you guys next time. Just keep on checking. If I will be online tomorrow, I'll post something during the day I'll post a picture with the times on my profile. Just keep on checking that tomorrow. But mostly the live videos will be on weekends. Friday evening, Saturday, and Sunday we'll have the live videos. During the week, I believe you have extra classes with the teachers, so you'll be knocking out very late. And yes, yeah, during the week you'll be doing other subjects also. But on weekends, we'll have these live sessions where we discuss and solve more questions. I want to upload a video tomorrow or on Tuesday, a video on organic chemistry. The whole how we start the organic chemistry and how we go about it. Yeah, from me guys, that's all. Thanks for watching, and yeah, good luck with your studies.